effective grid geometry due to material loading at tip. As shown in this image, this is geometry of material strips. This is a grind stage R2 and gamma 1. Generally, grid geometry may undergo substantial change due to the mechanical and chemical alterations leading to rounding or flattening of a sharp cutting points. This happens when the work material has harder or abrasive constituent. A chip material adhere to the tip of the grid because of some chemical and affinity can also change the effective range angle grid to leading to high grinding force. The temperature and poor performance of the grinding wheel. The next one is SiC silicon carbide and ferrous material. The silicon carbide abrasive are harder than friable aluminum Al2O2, but they are usually inferior for grinding most ferrous material. This is due to the dissociation of SiC to react with the adhere to iron at elevated temperature. Affinity of silicon or carbon for the workpiece. Therefore, SiC tend to work better than Al2O3 on some ferrous metal with excess carbon. The superiority of SiC on some cast irons is due to the presence of small amount of SiC as a normal constituent in the iron, which would have a more drastic effect on wear of the softer Al2O3. Next one is a grain size. The grain size is expressed in terms of CO number S1, which corresponds to the number of opening per linear inch. The diameter of an abrasive grain is given by Tg 0.6 divided by Sn. The larger the size of grain, more will be material removal, but the surface finish will be worse. The sieve number and types of grain: 10 to 24 coarse, 30 to 60 medium, 70 to 180 fine, 220 to 600 very fine. Grinding wheel structures. These are the different type of grinding wheels structures shown in the images. Open and dense. The dense spacing, medium spacing, open spacing. We have a lot of difference. Dense spacing is no space compared with medium spacing. This is a distance is high. Open spacing is more distance is high compared with the dense spacing and medium spacings. This is a pond materials, air gaps in white color, and abrasive grains is gray color. This is a bonding surface. Different type of bonds, bond fracture, grain size. This is a bond porosity mentioned here. This is a grain size. This is a bonding fractures between the two bond. This is a micro cracks. This mentioned in the red color, highlighted by the micro cracks. These lines called as a grain fractures. They have a difference between micro cracks and grain fractures. This is a artitious, highlighted by the black color, wear, artitudous wears. This is a wheel surface. This is called as a porosity. These are the structures of grinding wheels.